In this lecture, we will discuss about some problem solving techniques on energy meter. So our first problem is, an energy meter disc makes 10 revolutions in 100 seconds when a load of 450 watt is connected to it. Determine the meter constant in revolution per kilowatt hour. Now what is revolution per kilowatt hour? If this is the aluminum disc of the energy meter, then for recording 1 kilowatt hour energy, how many revolutions it is making? Suppose it makes 200 revolutions for recording 1 kilowatt hour energy. That means for recording 4 kilowatt hour energy, it will revolve 200 into 4, that is 800 times. So for 1 kilowatt hour energy measurement, how many revolutions it needs to do is called meter constant of that particular meter. The value of this meter constant varies from one meter to another. Clear? Now what is our objective? Our objective is to measure or to determine the number of revolution for 1 kilowatt hour energy. Now in the question, what data has been given? It is wattage, that is 450 watt, and time, that is 100 seconds. So energy is equal to power into time, we know that. So how much power is given here? 450 watt. And how much time is given here? 100 seconds. Now if I want to get the unit of these things, that is 450 into 100, it will be in watt second, because this is watt and this is in second. Now we have to convert this watt second into kilowatt hour. For that, what we need to do? We have to simply divide this into with 1000, that is converting it into kilo, and 3600, because 1 hour is equal to 3600 seconds. So it is converting it into kilowatt hour. Now this unit is kilowatt hour. So this much of kilowatt hour requires 10 revolution according to the question. Now for 1 kilowatt hour, how many revolutions the meter disc will do? So that is a simple calculation. This is equal to 800 revolution by kilowatt hour. So our meter constant is 800 revolution per kilowatt hour. This is our answer. Now in the second question, we have exactly the opposite parameter to determine that we have done in our previous problem. That is, in previous problem we have determined the meter constant, and now we have to determine the load in kilowatt hour. So what is given in the question? The question says the energy meter has a meter constant of 1200 revolutions per kilowatt hour and makes 20 revolutions in 30 seconds. Clear? That means for 1 kilowatt hour energy measurement, it rotates 1200 times. Now it is rotating 20 revolutions in 30 seconds. So 1200 revolutions for 1 kilowatt hour energy measurement. So 1 revolution for 1 by 1200 kilowatt energy measurement, and according to the question, it is 20 revolutions required for this much of energy measurement. That is roughly 1 by 60 kilowatt hour. Now if we try to convert this kilowatt hour energy into watt second, then what we need to do? So we have to simply multiply it with 1000 and 360. So that is equal to this much of watt second. Now look at the question. This revolutions is done in 30 seconds. So this is watt second. If we want to determine only the value of watt or the load, then we have to divide it with number of seconds. Then only this seconds and the second will be cancelled out and we will get only the wattage. So how could we do that? We can simply do it by this watt second divided by 30 seconds, that is given in the question, and we get 2000 watt or 2 kilowatt. So our answer is the load is 2 kilowatt, for which the Energymeter is making 20 revolutions in 30 seconds. So our answer is 2 kilowatt. Now here we have another type of problem, that is determination of percentage error in Energymeter. So let us look at the question. A 230 volt 5 ampere Energymeter on full load unity power factor test makes 60 revolutions in 360 seconds. If the design speed of the disk is 520 revolutions per kilowatt hour, find the percentage error. So first understand the question. Before installation or making the large scale production, the meters are generally tested, and the process by which the meter is tested called phantom loading. Though this is not important for this problem solving purpose, but for your general awareness I am giving you the information. Okay, so whenever it is tested, it is found that the meter is making 60 revolutions in 360 seconds. Clear? As per the maker's design, the meter should revolve 520 revolutions for 1 kilowatt hour load. So will it have 520 revolutions, or more than 520, or less than 520 in 1 hour? That needs to be determined by seeing these 60 revolutions in 360 seconds. So the same thing, first we need to determine that how much energy consumed by the load in 360 seconds. Okay, so total energy consumption of the load in 360 seconds is Vi cos phi into T. Now according to the question, V is 230, I is 5 ampere, power factor is unity, so that it is equal to 1, and time is 360 seconds. Now we have to convert it into kilowatt hour, so we have to divide it with 1000 and 3600. So we get 0.115 kilowatt hour. Clear? So for measuring 0.115 kilowatt hour, the meter has rotated, or the disk has rotated 60 revolutions. Now as per this speed, for measuring 1 kilowatt hour, how much revolution the meter will do? So for 0.115 kilowatt hour, Energymeter rotates 60 revolution. For 1 kilowatt hour, the Energymeter will rotate 1 divided by 0.115 into 60, that means 521.739 revolution. But according to the question, what is the manufacturer design? It is 520 revolutions per kilowatt hour, but the meter is rotating 521.739 revolution for measuring 1 kilowatt hour energy. So the meter is running faster. So what is the percentage error of this meter now? It is measured value minus true value by true value into 100. So this is equal to approximately 0.34%. So this is the percentage error of the energy meter that has been manufactured or designed or has been found during the testing. Thank you.